Okay, so this is the last component of our arithmetic sequences notes for this week. And we're going to conclude it with this idea of an arithmetic series. So you'll see here, a series is defined as a sum of an indicated number of terms of a sequence. So for example, if I take 1 plus 3 plus 5 plus 7 plus 9, I'm taking the sum of the first 5 terms of the sequence 1, 3, 5, 7, 9, 11, 13, dot, 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 dot. So I know that I'm taking the first 5 terms because there are 5 of them here, right? We've just taken the first 5 terms and we've gone ahead and added them up. So instead of just listing them, we can actually look at adding these values together. We're going to use this notation here, S sub n, so it's capital S sub n, to denote the series or sum of n numbers of terms. So for example, when I looked above at the 1 plus 3 plus 5 plus 7 plus 9, I can see that that is 25. Since I took 5 terms, so the number of terms here is 5, that tells me that I'm calculating S sub 5. Okay, so instead of S sub n, I'm calculating S sub 5 because I'm looking at the sum of 5 terms. So S sub 5 given that sequence is equal to 25. And just like previously in these videos and notes, we have a formula that we're going to use for when we find the sum of the terms of an arithmetic sequence. Okay, so this right here is that new notation of S sub n, but everything else should look kind of familiar, right? We have n, which is whatever number we're ending at. So in that example above, it would have been 5. We have a sub 1, which is our first term. And we have a sub n, which is our nth term. Okay, and notice something pretty important here is that your a sub n is that number, right? The number term that you're ending on is corresponding with the n here, and also the n in the subscript of your sum. Okay, so let's kind of unpack this and work to understand this a bit better, this formula and the use of it in example 8. So we're asked to find S sub 10 of the sequence 3, 5, 7, 9. So another way to be asked of this question is find the sum of the first 10 terms of that sequence. Okay, so that's another comparable way of asking you this question. But either way, we're going to rely heavily on that formula. So I think the most helpful first step is to plug in n equals 10 to our equation. Okay, so what that means is we're looking at S sub 10, right? Remember, S sub 10 is the sum of the first 10 terms from a given sequence. S sub 10 is going to be 10 times the first term of that sequence plus the 10th term of that sequence, all divided by 2. Okay? So there's a lot of components to this, right? In order to find this sum, we need to know our first term and our 10th term. And we could maybe do that here in this case by just continuing the pattern, but I want to practice the skill of writing out our explicit equation. Okay, so our next step is to find any missing information. And what I mean by that is find any information that we're going to need to calculate the S sub 10 that we're not already given. Okay, and it looks like really all that is, the missing information would be this A sub 10, okay, because I know A sub 1 is 5, and I've plugged in 10, and I have the 2 from the equation, so really all I need to do is find A sub 10. Okay, and again, like I mentioned, in this example, we wouldn't have to continue or extend this pattern, the sequence too far out, just repeatedly adding 2's to figure out A sub 10, but in other cases it might be helpful to be able to write the explicit equation and go ahead and utilize that. So I'm going to demonstrate that here. So using strategies that we saw in examples 3 through 5, we can see that the explicit formula that represents a sequence is going to be a sub n is equal to our first term, 3, plus our common difference, which after I look at that sequence, I notice is 2, times n minus 1. Okay, I can go ahead and clean that up a little bit. I see that that's 3 plus 2n minus 2, which is just telling us that a sub n is equal to 2n plus 1. And that's helpful because I can go ahead and snag that value of 10 and plug it in anywhere where there's an n. So I'm going to let n equal 10 in order to calculate a sub 10. So a sub 10 is equal to 2 times 10 plus 1, which is just equal to 21. And this allows me to fill in the rest of my s sub 10 equation. Okay, so my s sub 10 equation is going to be kind of step 3, or well, I guess step 2 on your guided note says identify the missing information, and step 3 is find the missing information. So if you're comparing this with the guided notes that I had typed up, this right here is kind of step 2 and step 3, right? We've identified that we need to figure out a sub 10, and then we've just found it. So step 4 is going to be plug in to the s sub 10 equation. Okay, so that's taking our s sub 10 equation that was above and filling in all those missing pieces. So we were given that n equaled 10. We were given in the problem statement that a sub 1 was 3. We just found that a sub 10 is 21, and we need to divide that by 2. So that means that the sum of the first 10 terms of the sequence is 10 times 24 divided by 2, which is 240 divided by 2, or simply 120. So our solution, our value of s sub 10, or aka the sum of the first 10 terms of our sequence, is 120. And utilizing that formula is a lot nicer, a lot more efficient as far as time is concerned than just like listing out those first 10 terms and actually adding them up over and over again. Okay, and you'll see in example 9, the use of all the formulas kind of is pretty apparent. Okay, so example 9 tells us to find the sum of the first 100 terms of the sequence negative 18, negative 13, negative 8, negative 3, and 2. Okay, so right off the bat, what I recognize is that if I'm asked to find the sum of the first 100 terms, that means that n is equal to 100, and I'm going to calculate that formula for s sub 100. Okay, so just like in example 9, I'm going to go ahead and kind of break this into steps for myself. So step 1, I'm going to plug in n equals 100, which tells me that I'm looking to take 100 times a sub 1 plus a sub 100 and divide it by 2. Just like before, we were given our a sub 1. Our a sub 1 is a value of negative 18, but we don't know a sub 100. Okay, so step 2, I'll do a better job of breaking up these steps here. Step 2 is identify missing information, right? What is the value or values that you don't yet know that are preventing you from just straight up calculating s sub 100? So identifying that missing info, in this case, that would be a sub 100. We don't know what that guy is, okay? So step 3 is going to be find that missing information. So actually finding a sub 100, and we're going to rely on those examples 3 through 5 again to go ahead and do this in like a pretty quick way, right? It would take us a long time to write out all 100 terms. and instead what it would be best is just to utilize our practices and strategies from before to go ahead and write the explicit formula. So the explicit formula for this sequence, we know because it's arithmetic, you take a sub n, set that equal to a sub 1, which in this case is negative 18, and then you add to that your common difference. It looks like to get from negative 18 to negative 13 to negative 8 to negative 3 to 2 is a common difference of positive 5. And I'll go ahead and multiply that by n minus 1. So that tells us that our explicit formula is negative 18 plus 5n minus 5, which can simplify to a sub n equals 5n minus 23. And it's helpful to pause and think, wait, why was I doing that again? It's to help myself figure out what is my a sub 100 term. So letting n equal 100, we can find that a sub 100 is equal to 5 times 100 minus 23. Okay, simplifying that, we find that a sub 100 is equal to 500 minus 23, which would be 477. Okay, so we have all the pieces now in order to compute s sub 100, in order to figure out the sum of the first 100 terms of this sequence. So again, just like in example 8, our next step is plug in values to s sub 100. Okay, so stealing that equation from above, we already had s sub 100 equals the 100 terms that we're summing. The a sub 1, our first term, was negative 18, but we can now introduce our a sub 100 term, right, our 100th term in our sequence that we found using our explicit formula above, and then divided by 2. Okay, so this is equal to 45,900 divided by 2, which tells us, so our solution, the value of the sum of the first 100 terms of our sequence is, I believe, 22,950. Okay, so go ahead and use this video and these examples as well as your guided notes to try and tackle practices 10 and 11. You're going to find that those are pretty straightforward, and then there's a challenge question, but I'm confident that if you kind of think through the information that you're given as well as this equation for the sum of the sequence, or the sum of the terms of a sequence, I think you guys can handle that. As always, make sure you're reaching out via email or during office hours if you have any questions.